Hello. So this is our Morse code translator device for Senior Design 2. Our goal was to make a small standalone educational device that would be able to teach people how to use and translate between Morse code and English, and this is the final product. So we wanted it to be a pretty portable, small, easy to use unit with minimal controls. It has a 4.3-inch touchscreen. It has a LiPo battery inside it, and it's powered by a Raspberry Pi. There are some controls on the side too for muting this speaker, powering it on and off, and then choosing your translation mode. These controls are for navigating in the menu, and that's the enter key. And then these were labeled, but with our 3D print they didn't come out well, so you can't read the labels. But this is our manual Morse button, so if you want to manually key in a Morse input, you can use that. This button is our record button, and then this button is the backspace or clear. So I guess I'll go ahead and power it on. We have a power light to show the status of that. Up here, we were going to have a Morse LED to show the output of that, but we, due to our time constraints and some issues with our interaction with the speaker and that on the same pin, we had to remove that for now. And then this is our microphone input for receiving audio, because this can take in either English or Morse text, or it can translate English audio to Morse. So once the Pi boots up, normally you'd be able to set it so the Raspberry Pi can automatically boot up to a certain program, but we did not get to that in time. So for now, you just click on that and then open up our program and run it. So there's our main menu. So we didn't want too many options for the user to mess with, so we just have a few options on the main screen. So depending on what you have the mode selection switch set to, you can either do text translation or audio translation. And then we have a special little mode called lowercase Morse, and that was kind of our take on adapting Morse code to allow for lowercase and uppercase letters, because traditionally Morse code is just all caps essentially. And then we also have our Morse code game. That's a fun game you can do where it plays out that noise that you just heard earlier, and then you can try and guess what word was playing. And if you're correct, it'll say you're correct, or you can try again. And then lastly, we have a terminate program button to exit this. So I guess we'll start in, the top is English mode. So we're in there. If we go to text translation, you get this menu with a keyboard, and there's a little text dialog box there. You can type in whatever you want, so I guess I'll type in, let's see, Morse. Oh, where's the button? Oh, little typo there. If you do typo, you can click on wherever you want and clear it and rewrite it. And this is a complete custom keyboard that we had to make to get this working. Since the Raspberry Pi isn't traditionally designed to be kind of a handheld device, we had to do a lot of custom things, and we fought with this GUI a lot trying to get that to work. Okay, so I guess I'll do Morse code game. And then once you're done, you can hit submit at the bottom, and then it'll translate that to Morse code. It's kind of small and hard to see, but so for, oh, I typoed. But that's the gist of that. And then to exit, you just hit the back button and it goes back. And now if we change the mode to the Morse input, if we hit text translation again, now you can type in dots and dashes. I don't have a sheet on me, but so I just typed in 1 dot. If I submit that, it gives me E, which I believe that's correct. And then if you clear that, type in 4 dots, that's an H. And those are the only two I really remember off the top of my head. So you can type in whatever you want. You can do a dot. Oh, that's not a dot. Dot, space, dot, 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 dot. Mess that up. Oh, well, that's the text translation. Then for the manual Morse input, if you click on the text translation, you'll get a pop-up saying the press button and then hold for a second for a dash. So you tap it for a dot and you hold it for more than a second for a dash. So it's a bit of a lengthy time, but it makes it easier for newer people to get it. So there's a 20-second window to do this, so if you just tap it and then wait for that 20 seconds to time out, it'll spit out whatever you put. So the single tap should be an E, so once that 20 seconds is up, we'll get a little pop-up that'll show we had an E input. And there you go, there's an E. If we do it again, hit OK, and then do 4 dots, it should do an H. And again, you gotta wait for that time window. We could change that so that way that it actually, once it stops reading for a certain period, it'll end it. And so there you go. See, we got an H. Now, if you do audio translation, we were having issues getting our microphone to work with the Pi, so unfortunately on the physical model it doesn't work. But if you run this on a computer and use your computer microphone input, it will translate your English audio input to text, and then it'll translate that. So we just have a filler in here for now. So there you can press record, and then it'll record for a bit, and we just have a filler, as I said, so should stop translating. Oop. And it should spit out something. I don't recall. Oh, yep, there you go. So there it spits out the translated audio. Okay, and next up we have the Morse code game. So this will play an audio out of this speaker on the back in Morse code. And there's a mute switch if you don't want to hear it, which would take the place of that, and that also mutes the Morse output when you're in the English to Morse mode if you do have it outputting Morse. So after it plays that audio, you get the input screen, and from here you can type in what you think the word is. So if we just put hello, sorry, that's incorrect, then you can try it again. So that's our little mini game mode, and that's the basics of our device. So it is wireless. There's a LiPo in the back of here. You can charge it with a basic USB cord, and then it can last for a pretty long while. Supposedly the battery and all the LCD and the Pi and the current draw from the buttons and speaker, it should be about like a 30-minute to 45-minute battery life. But yep, so that's our finished product.